Hey there, let's go ahead and look at the chapter 8.1 from the 6th grade textbook, and it also works pretty well with 3.3 of the 7th grade textbook. So let's take a peek. We are talking about writing and even sometimes evaluating algebraic expressions. Basically, what that means is we are putting some sort of expression together with terms that has to do with a series of sentences or words that are put together to show us with language exactly what a particular expression would look like. So for instance, it's really important to realize that a lot of the expressions that you're going to hear are going to ask you to find a number. Now, if we don't know exactly what that number is, it's considered a variable, so we're going to use some sort of letter to represent that variable. So for instance, if we were told that we needed to find 3.2 less than a number, we can go ahead and write that out. 3.2 less than a number. Forgive the shorthand. 3.2 is very obvious for us. We can see that it is a number on its own. It's going to be a part of our problem. But let's look at the rest of this. It says 3.2 less than. Less than means to subtract. And let's look at the last part here. 3.2 less than a number. So a number is going to be our variable, or whatever letter that we're going to use to represent the missing piece of our problem here. So the first thing that translates really easy is the subtract. Less than is subtract. 3.2 less than means that you are subtracting 3.2 from something. Out of what's left in this expression, what could we subtract from? We could subtract from the variable. The variable you choose could be any letter that you wanted, X, Y, Z, Q, T, whatever you would like it to be. When I first start teaching expressions and variables with students, sometimes I have them draw hearts and smiley faces or things like that. But for the sake of the algebraic video and simplicity, we will choose X. X minus 3.2 is the same as 3.2 less than a number. So let's look at another one. Let's say, for instance, n more than 5. N more than 5. Now, interestingly enough, instead of saying something like a number, what's listed here as our variable is n. N just means we have an area that we are going to be able to substitute particular values for later. We don't currently know what that is now, so we're going to say n. N more than translates to addition. And then you have the number 5. Just a typical number that we are going to put in our problem. So n more than means that we are going to be adding n to something. N more than. So if we put a number in this phrase instead of n, just to get an idea of what it sounded like, it would be something like 1 more than 5, 2 more than 5, 0 more than 5. We know that whatever number could be there is going to push our sum past 5. And we also know, or below it if it's a negative number, and we also know that we are adding it at the end based off of that information. So the 5, being the only piece that's left, has to be the first addend of that problem. Let's see what else we can do. Let's look at, for instance, something that sounds a little bit like 8 more than 7 times a number. So I'll write that one. 8 more than 7 times a number. So here we go again. We are looking at something very similar to the last one, where we have 8, a regular number in here, but 8 what? What are we doing with 8? And we can go ahead and include that next set of words there, more than. 8 more than. So that automatically translates to plus 8. Let's look at what else we can find. 8 more than 7 times a number. If we needed to break this up, we could have broken it up right here. We could have gone ahead and said 7 times a number. What does that mean? Well, 7 times something. Times means multiply. So in this instance, we would be doing some sort of multiplication problem where we are multiplying by 7. Well, we have this part here again where it says that we're multiplying by a number. Well, what number? And in this case, we're going to choose a variable to put in here because we don't know exactly what that number is. So we can say our number is going to be x. Whatever is going to stand in that place will be perfect. And we also need to know that it's 7 times that number. So we could say 7x. We could say 7.x, which a dot in the middle like this that's floating can be a representation of multiplication. We could put the x in parentheses so that we're saying those two terms that are smushed together are meaning multiplication, or we could just do 7 times x. In this instance, we probably should have chose something different than x so that we can tell the difference between our multiplication and our variable. So let's say v. These are super important because we're trying to get them in the correct order so that we can actually do the order of operations later on. So sometimes you'll be asked something like to write the product of n and 3. In this instance, we are looking at the word product. And we need to realize that product means multiply. So product is going to translate into our multiplication symbol, and the 2 factors that we're using here are the 2 numbers that are listed, n being the variable, and 3 being the number. So your expression here is n times 3. Maybe you're going to see something that says the quotient when 3a is divided by 4. Quotient means divide. The quotient when 3a is divided by 4. So if we went back and we read this, we would say 3a divided by 4. It translates as an expression the same way that the words do that we just read. Maybe you're going to hear something that says r to the 4th power. In this instance, r is your variable, And we're being asked to place this variable with an exponent of 4. Fourth power representing the exponent